Okay, welcome back from the break. Let's continue straight on with our next speaker with his talk, 5 tips to create a secure Docker container for Java developers. He's a software engineer and developer for Snyk. You've seen him speak at meetups and conferences around the world, and he's single-handedly making the world a more safe and secure place. Ladies and gentlemen, Brian Vermeer.
Wow, that's quite an introduction, Wouter. Thanks. Single-handedly making the world a better place. That's well, please take that weight off my shoulder, because that chip on my shoulder is way too heavy. But hey, welcome. I'm enjoying my coffee. Hope you have some. And we are going to talk about security and about container security in this case, but specifically for Java developers. So, but we have to talk about something first, because let's talk about this term, container. What is a container? And we always want to grasp software concepts and compare them to real world things, right? So if we look at container, we can look at containers like this. This is the well-known soda can or the beer can. We can look at a container like this one, which might be the airtight container where you put your food in to let it, well, keep it crisp or let the flavors in, make sure that it's good and well preserved. Or as a more larger concept, we love to look at containers like this, the shipping container that you put on a boat or a ship, on a train or on a truck. And all these things are basically receptacles for holding goods or portable compartments which well, objects or freight is placed. And all of these three things have one thing in common. They are a protective barrier against the outside world. They try to minimize the influence from the outside world to the containment. So, well, might be obvious, but the soda container is there to keep the flavors in, and that shipping container is there that if you transport goods, that they will stay intact. However, it is very, very important that you pick the right container. And again, for a real world thing, that seems logical, seems obvious. However, if we transport that concept to software, are we doing that? Or are we putting our beer without the container in a shipping container, like the one below? That doesn't help. So pick the right container is one thing. Secondly, this container is some sort of security barrier for the outside world, because we don't want the outside world to get in. However, there is a concept that people think that if we put software in a container, like we do here, say we have this container and I put my Java program in, that by putting it in the container, by default, it is safe, because we had that analogy of that real life container. Unfortunately, this is not true. And that's because of a simple concept. We have two-way traffic. We need to get in and outside that container. If that container is there on its place and we don't do anything with it, perfectly fine. Then you're at the right point. However, we need to interact with it, like make sure that we can have data from a user or from a database, send data out, make sure that, well, basically it's a container with holes in it, but specific holes. So putting a Java application inside a Docker container, because I will focus on Docker this time, doesn't make it safe by default. You have to do something. It is another layer of abstraction, but you need to take care of that. Hold that thought. Hi, for those who don't know me, and probably a lot of you, that's no problem. My name is Brian, and you see this is a picture pre-corona time. You see the difference, right? Hopefully hairdressers will actually open up at the end of the week or beginning of next week, and I will be more like this on the picture. However, I do a bunch of stuff in the community, and I'm a developer advocate for Snyk, and well, that means I'm developing and I'm advocating. I do some stuff for the virtual JUG, and I see this as an old slide because until last week, I was a co-leader of the Utrecht JUG, but I recently announced to the members that I will, well, give up my place in the board over there because something happened last week. I was announced as the board member of the NL JUG, one of the board members, one of the technical board members. So you will be seeing me in another position if you are an NL JUG member. However, this is all fun and stuff. This is me. You're not here for me. You're here about the subject about containers. And we're going to talk about Docker containers because Docker containers, there are a lot of them and people are using them quite often For instance, 1 billion weekly downloads of containers, and that was in somewhere in 2020. I don't know what the current number is. Regardless, it means there are a lot of Docker containers. And what we do with Docker containers is we pick a Docker container from Docker Hub and we build our stuff on top of that. Hold the thought again, because I will give you 5 tips not to fail your security. First one, I already said that we pick a container from Docker Hub. That's in many cases what we do. But we have to make sure that we choose the right Docker base image for your Java application. Not any Docker image is good enough. Again, you don't want to store your soda without the can in a large shipping container. Doesn't make sense. Same analogy holds for software or for your Java Docker containers. For instance, from Ubuntu, this is how we start. Like, we take an image from an operating system in most cases. And then, well, what we did somewhere in 2019, I did a research on Docker containers, and I downloaded the 10 top Docker containers, the 10 free Docker containers, top 10 free Docker containers from Docker Hub, and we scanned them with our stuff at Snyk to see if there are vulnerabilities in it. Long story short, all 10 had vulnerabilities. And that can be from 500 something to 31. And you saw already in the previous thing, I said from Ubuntu. I didn't specify any tag or something like that. That's what I did here as well. So by default, we take the latest container. That means by default, I have no clue what's happening there. In this case, the default container for Node, for instance, depends on a very large Debian distribution. And think about it. Is that something that we need for a Java application? Do we need a full-blown application or a full-blown operating system for our Docker containers? Probably not. However, in many cases, and if we look at tutorials on Stack Overflow or whatever, we see these kind of things. And if we look closer at the containers, actually the open source or the operating system containers, we see there is a large difference between which operating system I use. So if I use a Debian-based operating system or a Debian Stretch Slim based container, that already gives me a lot less vulnerabilities. And these vulnerabilities are there in the binaries that ship with that container. So you might not directly use them, but you're not sure, because it might be that the library in your application uses them, or that through different holes you can do that. If you think about security, it's not only like, this will not harm me because I never call this. It's always, well, somebody once told me, security is like Swiss cheese. There are holes everywhere. So if you go in one hole and you can connect that to another hole and to another hole and to another, then it might be vulnerable. It's like an onion. Make sure that every layer is secure. So why do you want to hold binaries that you don't use or are not useful for your application or for the functionality that you want to encapsulate? If we take a more Java approach and we look at the adopt OpenJDK for OpenJDK 11 images on Docker Hub, and I scanned them, I think a couple of months ago, and you see that there's a difference as well. The latest by default is an Ubuntu version that has 25 vulnerabilities. But if I specifically take the Debian one, so the JDK binaries are still the same, but based on another operating system, I bring in a bunch of more binaries. Ends up in a lot more vulnerabilities. For Alpine at that point, it was 0, because at that point, there were no known vulnerabilities for the Alpine version. I scanned them just before this, just before this meeting. And let me show you the current results. So not like, yeah, you did this once and now it's all better. If I'm looking at, let me just recapture my screen. This one over here was the Debian package. You see that in the bottom, you see that there was the original command. I did a Docker Snyk container test on the OpenJDK Debian, and we see that there are 80 vulnerabilities found, and all these 80 vulnerabilities are somewhere in this Debian thing. So that means that if you take a Maven package or a Maven-based image that is based on Debian, because it is a cascading thing, you will have all these vulnerabilities for free. Taking The same OpenJDK version, but the latest one, which is based on Ubuntu, already gives you 23. So picking your base image is like building the foundation for your home, for a real life structure. It has to be solid. So from that fashion, we know that we need to investigate where we base our stuff upon. But then we only need to use what we actually need. And that sounds obvious again. But let's go to a very naive way of building a Docker image. Like this. If you look at the majority of the blog posts, like how to create a Spring Boot application with Docker, you find something like this. And what I do over here is quite obvious. I'm using a Open JDK 11 Maven 3 image, so that has Open JDK 11 and Maven 3 already streamlined in it, and I built my stuff on top of that. I create a directory, I copy all my source files over there, make sure that there's a work directory, and I call Maven package to do this. Let's just do this. I have the Docker file over here, as you can see, basically the same Docker file, and let's just do this. So I'm Docker building this image with this is the Docker build -t JCW, which stands for Java Code Workshop, which I created a bunch of time ago, just as an example. And I gave it a tag 1. So let's build this one and let's see how it works. And I already have the images that is based upon, so it doesn't need to take a lot of time. But let's go back to the image definition first, because now it's downloading all sorts of things from Maven. But if we look at this image declaration, we see a few things that are interesting to us. OpenJDK, Maven, and then we use Maven to run your Spring Boot application. So basically what you do is you download the whole JDK, you put your code in it, you use Maven to compile and build the code to an executable, or well, in this case, an executable jar, and you use Maven again to run it. But if we look at what we actually need in production, is that what we need? We don't, because in the old days where we were working with IBM WebSphere and that kind of stuff, we build WAR files. In this case, we only need the jar file. So you only need the product of what you created. That also means that you don't need the whole JDK. You don't need the whole JDK. You only need a Java runtime environment. And it means that the JDK ships with a Java runtime environment, obviously, but you don't need the whole JDK. You obviously don't need Maven. Moreover, if you do this, there is a chance that if somebody can get into your container, the code is there, the build environment is there, that somebody can seamlessly change some things, maybe restart the container without you even knowing it. And that is not what you want, right? So looking at this part and looking back at the application over here, we created the container, cool. So let's just look at it, how big it is. Docker image ls. And we see that JCW1 is large. It's like 800 something, almost 900 megabytes large. And that's not what we do. That's not what we want. That's not what we want to put in production if we think about production-based images. What do we need? Well, what we can do is we can build on our local machine and then put it in an image, or we can use the so-called multi-layer, multi-stage builds in Docker to do this. So I can do something like this. And well, I prepared it, so let's not do this. Let's skip this one. And I already prepared it over here, the second part. So what I'm doing here is I am using the first image to build my stuff, which is perfectly fine. But then I only use the product to copy that over to a second image that I'm creating that only contains a very small Java runtime environment based on an Alpine image of OpenJDK. So an OpenJDK Alpine, which is already small, Java runtime image. I only have the jar, and I simply call a Java -jar to create the stuff. If I do this, And let's make this number 2, and let's build this one. We will see that obviously this image is a large, it's already there, successfully tagged. That's cool. I probably did something wrong. Well, never mind. Let's go back to the slides because, hey, if everything else fails, this one 800 something, you see already that it was larger than that, but your build image doesn't need to be your production image. If you split the two, as I just showed you, in this case that we changed it and the naming is a little bit different, but we see that it's smaller than this. And the most important part is because it's smaller, it doesn't contain all the things that we do not need, which, well, clean desk policy kind of. However, if you need to put other things in your build image and you don't want to do, you want to do this in a Docker file. Let's keep that as a certainty. If you want to do everything in a Docker file, like building and producing the production image, we don't want to have things in like passwords or secrets or that. And if you do a Docker history on a certain image, you will see what happened basically. And you see that if you do that on your production image and you put in passwords or you punch in secrets, you will see that they are visible in these caching layers. However, if you do this in a multi-stage build, for instance, like this, say my repo name uses a username and a password like this. Hopefully you don't, but just for the sake of argument, if I do this in my build image, it will get thrown away eventually because only the production image will stay there. So this is a good way to separate these two concerns. Let's go to the next one, which is the least privilege principle. Well, the least privileged user in this case. Because think about it. You're in a hospital and something is wrong with you. Do you want every single person in that hospital, like every nurse, every doctor, even the janitor, that he or she knows what is wrong with you? Probably not. Same holds for software. What do we need? And only the stuff that we need to do, we are allowed to do. Nothing more, nothing less. The problem is only, like if we look at images like we did before over here, that same multi-stage image, it looks fine, right? Only I'm not actually creating a specific user for this. If I'm not creating a specific user for a Docker container, by default, Docker will run your stuff as a root user, which may be fine for a very small container because we already stripped all the things off, but that's not what you want. You shouldn't be doing that. You have to make sure that if we want that, and we're talking about that lower part, so that production image, we actually want to create a user that is only can specifically do what needs to be done. So let's do this. The only thing that we have to do here is literally create a new user. Oh yeah, let me highlight the lines that are important. So what I'm doing here, and I'm using an Alpine image. So the terms and the commands are maybe a little bit different than are a little bit different than I usually do with Ubuntu or Debian. But it's basically the same because we create a group and we create basically a system user without shell access. And we bind that new user to that group. We make sure, in this case, I chose to make that user the owner of my project working directory. And don't forget that last yellow line, because that last yellow line makes sure that every command afterwards is called by that specific user. If I create a user, make it the owner, and not say user Brian Vermeer in this case, we will still run it as root. This also means that if you're using a base image that provides you already a specific user with less privileges, you need to call it. So make sure that you have a user that has, well, at least not the root privileges. So if something goes wrong, it's only in a bubble, which is a very hyped word now in these Corona days, right? Bubbles. Docker images and Java applications during development. I already showed you that I'm scanning my base image, but I can do basically the same with an image I created. Docker Snyk container test image, and I'm using tools because, well, they're free, you can use them, but there are multiple tools you can use. The most important part is that you have to use them, because if we And this is from the State of Open Source Security report that we published in 2019 and 2020, and basically had the same results. Like, when do you scan Docker images for operating system vulnerabilities? Half of them don't. Half of the people don't know that this is a thing. And it is a thing because, again, this is the foundation. It's not only the base image itself, but also the binaries that come with it that are your responsibility, because you don't just hand in the binary that's there because now we are doing DevOps and we need to be cloud native. We bring in the whole Docker image and we're responsible for the whole shebang. So what I can do, and I also already showed you that I can do something like, hey, I pull the latest OpenJDK 11 version, and I'm using my Snyk container test to give me an example like what's wrong with it. You will see it like here, like, hey, what vulnerabilities are there? And then you can decide, when you know which vulnerabilities there are, you can decide if you want to use this image or not. Maybe you want to create a specific image with just from the ground up and strip everything you like. Or you see that some vulnerabilities are there, like, okay, they are so not important to my use case, but then at least you make a conscious decision of what is going on. Moreover, if you've done this and you've done a great job by developing it and by scanning it and it's all cool, then you put it into production. But vulnerabilities will be found over time. So a good thing is to monitor these things. And we can do that the same by, instead of test, doing the second line to do a monitor. What it does, it takes a snapshot of that point in time and it will scan over time. And again, there are multiple tools to do this, but at least then you know, like, hey, this thing is in production. If something comes up, you know, and you're not in the dark. But next to that, we're talking about containers. There's something else in that container. That is your Java application. And this is the binary that is your Java application. And we already know this, right? Because this is the binary that I put in that airtight container in the first slide. But as you look at your application, you know that probably this small part is your code, because the rest is probably things like Spring Boot or Quarkus or whatever hype framework is nowadays popular, or whatever library you pull in. And that is for a good case, because we do not want to do boilerplate stuff. However, we take great pride in our code. We do code reviews and we do pair programming, and we do tests, we do mutation tests, and our code is excellent, maintainable, scalable, whateverable. But how about the rest? If we look at these, things, then for instance, if you look at Maven Central, and it's not so much the dependency that you pull in by using Maven or Gradle, but it's transitive. Just like pulling in the Docker container has a bunch of binaries, pulling in Spring Boot Starter brings you a whole shebang of other things. And I'm now saying Spring Boot because it's the most popular framework, but it's basically for any library, you should know what's going on. So what do you have in place for version management in that case? Do you have some review process in it? Or maybe you scan it. And what can go wrong in this case? Well, let me show you that. I have a small demo from a Spring Boot application in this case, and this is not the Spring Boot application I was looking for. Let me go to, I must have it somewhere. Here. This is a Spring Boot application, and this Spring Boot application is nothing really fancy. The Spring Boot application is a grocery list, and this grocery list, well, as you can see, and I will enlarge it so you actually can see what's going on. It has a bunch of groceries with a price. Not very interesting. Also, let me catch this and close this. Also, the items itself are not really important. It's just a simple podio with an ID, a name, and a cost, and some getters and setters. But I'm using Spring Boot 1 in this case, an old version of Spring Boot, and we all need to cope with legacy applications. And I'm using Spring Data with it, so I can extend the CRUD repository, which is fancy. So now I don't have to write all these CRUD info myself. I can do something like find by name and find all, and automatically it generates the actual stuff for, in this case, my database underneath it. What I'm doing as well is I have a REST repository resource, which is Spring Data REST. And it transforms my CRUD repository into a REST repository, into REST endpoints. And that's kind of cool because now I'm done with prototyping. I can work on my front end, right? And it all seems convenient. But let me just hope for the demo gods that they will actually run this stuff. Yes, go demo gods. Well, at least you can see this is not well prepared, or this is prepared but not videotaped. It is a real life thing. So let's go to, for instance, localhost 8080. And I can see that I have my hell browser. And what I can do here, I can do things like I go to item/1, and item/1 will give me, if my computer stops rambling, it will give me my first item in my grocery list, that beans for 50 cents. Cool. I can do all sort of things like you see that find by name. And if I do the name is beer, hey, this is now a REST endpoint. By doing this, it will give me the beer. Cool. So it works perfectly. My tests are running. I do mutation tests. I do every kind of test, every possible test, and it works fine. Because, hey, there's a big company behind this, this framework. Cool, right? It works. Don't touch it. Ship it. However, you already guessed it. There's a problem with it. And the problem is that if I'm going to my terminal, I will show you something. Let me show you the JSON. Well, let me show you the passwd by that case. So I'm going to copy paste this. Just 1 second, my bad, because my mouse is not working with me. Let me copy paste this URL. Do it over here. And what I'm doing here is I'm doing a curl patch request. And the content type is perfectly fine. It's JSON patch with some JSON in it. And this is the JSON. And the JSON is weird because what am I doing here? Well, I am utilizing the Spring expression language. In this case, if I do a patch request, I will get into an exceptional flow and I can utilize SPEL. And with the expression language in Spring, I am allowed to create new objects or call objects or do something, actually execute code. And what I'm doing here, I am getting the runtime and I'm executing something. In this case, I am calling the passwd file, as you can see here. But if I can call something that is there, I can also create files. I can might even delete files, or I can import a script and run that script later. And the fun thing is I'm running it at localhost 8080 items1. The one item, the first thing I showed you to give you the first item on my grocery list. And by doing this, you will see that in this case, it's my local machine, but I have access to my passwd file. The passwd file is available for a lot of people. But if I run this as root, like I showed you before in a container, I have access to the whole shebang. I have access to every executable in that Docker image. And if that executable can do something or something harmful, then it's interesting. Or even not so harmful, I can create an SSH tunnel to it or something like that. Problems with security are most of the time are cascading problems. Keep that in mind. So, okay, I am doing this and I need to scan my application. So if I'm scanning my application and I'm having my application over here, and I can do it either in my IDE or I can do it on the command line. Let's do it on the command line. I can do something like and again, I'm using my tools, but let's see what's going on. And this was the other application. This is not the vulnerable application, what's going on, but you will see already that I'm using an outdated Spring Boot version. I'm using 2.4.0. In this case, I have a problem with 2.4.0. There's a problem in Spring Data JPA and Spring Data REST in that application that I created my Docker container for. And I have to at least upgrade it to 2.4.1, which saves my problems. The other one over here, you see that I'm using the H2 database. It's a demo application and I did it on purpose. So I'm good with this one. So now if I just get rid of these problems and these cascading problems within my dependencies, and I'm using a Alpine Linux, for instance, base image, I'm quite secure. It's never 100% secure, but I'm aware of what's going on. Last thing number 5, build to rebuild. And that sounds, on one hand, that sounds weird, but also obvious. Say this is your Java application in your container. Well, most of the times, if you run a application in a container, you probably want to run different instances of it, right? Maybe on a cloud instance, maybe even elastically scaled. And most of the time, these things are containerized. So we have 3 instances of the same Java application running perfectly fine, harmoniously in production. And everything runs fine, and I have everything in place, including monitoring and logging and that kind of stuff. And now I found out that in pod 3, and I call it pod, but it can be instance 3 or whatever you name it, there is somebody malicious in it, a hacker. What is the first thing that I want to do? I know that it's exactly in pod 3 because for some reason I logged that and I monitor that and alarm bells go off. I want to blow that one up because then the immediate threat is gone. He might be able to do it again, but at least I'm sure that the active thing, I don't know how difficult it was, but he's gone. And what I want to do is I maybe want to spin up a new version. And a new version can be the same version, but you probably found out there is an issue somewhere. You fix the issue and you want to be able to spin up a new version of it. And then take the second one down, spin up a new version, take the third one down, etc. But you have to be aware that just putting a Java application in a container needs to be container aware. And of course, we need to make sure that you're using the right Java version. As you probably all know from Java 10, the JVM is container aware, but that's not what I'm talking about. I'm talking about things like persistent data in your container, like a database or persistent logging or caches. These things are natural for a standalone application, but you shouldn't be doing that in a Docker container. A Docker container should be disposable. You should be able to throw them away as easy as you created them. So you have to get them out of these containers, or at least make sure that they're auto-regenerating. So if you have a cache in it, make sure that it is a self-healing cache, like, well, for instance, in-memory data grid like Hazelcast or name any other of these things. If you have a local copy of the database, make sure that it actually syncs, because if you blow that container up, all your persistency is gone. So you need to get it either out of the way or make sure that you auto-regenerate it. So it already starts from the architecture of your application that you need to be aware of this. And did you know that 44% after Docker image vulnerabilities can be fixed by a newer base image, just by not even the Java application, but just switching out the base image, everything is good. But what is more importantly is, how do we find out about these things if you already deployed a container? A lot of people don't. And that is, in my case, that is disturbing. It is a significant thing that if you are in production and we take care of our application, it's one, but that next layer, the Docker image, and then we have that next layer, which is your infrastructure as code. These are things that we need to take care of as well as full DevOps or full stack developers. Moreover, this one is interesting, is that 20% of Docker image vulnerabilities can be fixed by just rebuilding them. Not even changing a letter, but just rebuilding them. And that is because a lot of people use these kind of way to write images. And this is, of course, not Java, but it's like I'm using an Ubuntu latest image. And we already know that the latest image today might be different from the latest image next week because, well, people upgrade images. It might be based on newer insights. People fix vulnerabilities. People, well, you know what I mean. Same holds for binaries that you pull in by, for instance, apt or other package managers. Even though your Java application didn't change, but if you build your Docker image like this, and that's a choice. I'm not saying it's wrong or right. I prefer to do it prefer to use not just the latest tag, but to prefer to use a hash for it, so that I have the exact image. But then again, we need to make sure that even though the Java application didn't change at all, that our container also, like the base images, also have newer versions. So by updating these base images, if you look, for instance, the latest tag, if you're not changing your code whatsoever, but you just rebuild that Docker image, you will see that over time things will be fixed. So by putting it to production and not looking at it anymore, you're making a horrible mistake. However, if you're rebuilding it, I would suggest that you make sure that you use the -- no cache option in this case, because, well, things go wrong. I don't trust machines at all. And now I'm sure that Docker will not have a cache hit. Just saying. I will conclude with a small summary of this. And these are just 5 things. We have more. We have a lot more, but I only had half an hour. So first of all, choose the right base image. How do I need to build my foundation? And secondly, only pull in what you need. We don't need a JDK. Java runtime environment is enough for the production stuff. Never, ever, 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 ever run your container as root, even though you can be aware that you don't need to. And even though you can create a specific user for that, but I already explained it. Scan your apps and your images for during development, but also afterwards. Like when it's in production, keep scanning them, keep monitoring them, and build to rebuild. At any point in time, you should be able to demolish one of your containers and spin a new one up. If that is the case, then you already have a nice, proper, scalable architecture from a security point of view. If you want to know more about this, I recently created a 10 best practices for Java containers for my company Snyk, and 5 of these I just picked out and are over here. Other things I say, for instance, are, hey, you have to be aware that you use the correct Java image. Maybe you shouldn't be using the Java command as process ID 0, but use, for instance, .init for it, etc., etc. This is the one pager, but you can read the whole blog on the URL below. Last, but certainly not least, every year we're doing a research to what the JVMC ecosystem is, and I recently created the next survey, and I want to ask you all, please go there and please fill in what your situation is. What JDK are you using? What Java version are you on? What is your favorite IDE? And you can choose more than one. So it's not like I have to choose between my 2 babies, IntelliJ or Eclipse. If you're using both, you're allowed to choose both this time. So we want to get an accurate image of what the Java ecosystem will be, so I can create a nice report out of that. That's it. Thank you. If you have any questions, you can always ping me on Twitter, and you probably have in the YouTube chat already, but I didn't pay attention to that chat. Hopefully either Wouter or Bejan did. So I want to give them the word.
Awesome. Thank you, Brian, for your talk. Hopefully the world be a little bit more secure after your tips and tricks. We got a couple of questions from the audience. Nick Stolwijk starts off with Spring Boot now makes the images itself with build packs. Is that secure, or should we change something about that image also?
Yeah, that's a very good question. You have you can have the plugin from Spring Boot to create the Docker images, or you can use things like Jib to do that. For some people known, I won't say it's bad. I won't either say it's good. You have to be aware of what you're doing, because if you're using stuff blindly, you have no clue what's in it. So I did it last week or 2 weeks ago, honestly. And even in the build packs, there are vulnerabilities, because these build packs are also based on slimmed down versions of operating system. And you should be aware of what you're doing. Next of it, it's still a Docker image. Are you certain that, for instance, it's not using the root user? And you can do all these kind of things. So I'm not saying it's bad. It depends on what your situation is. If you use it, for instance, for internal testing or whatever, that's perfectly fine. But if you go to production, you have to make sure that all these other steps are also met. So are there binaries in there that you don't use? Or do you blindly trust Spring? That is a question up to you that only you can answer.
Fair enough. Another question by Nick Stolwijk. At one point you were talking about that there might be some malicious activity in a Docker container. And he asks a question about that. With Hazelcast, the cache survives the container can already be compromised. Shouldn't you wipe the cache after a break-in?
Absolutely. You can. Again, it depends on what you. If the cache is compromised, definitely. If that is part of your thing, the cache could be wiped. It depends if there are things in it that he or she can write to it. If it's, for instance, a read-only access on that cache, it's not a big problem. Yes, the stuff is stolen. That's you can count on that. But if it's not manipulated, maybe not. So it depends on where you are. I know systems. I've worked on systems where we had different systems that can only write and some systems that can only read. So it probably depends on your situation again. I look like a consultant now, right? With saying it depends. I'm sorry. It always depends. It always depends. But yes, in many cases that is the case. However, you should be aware that these things that I think it's obvious that if you put persistent stuff in your container and you blow your container up, you're lost it. That's the whole thing that I wanted to mention.
Yeah, cool. So I'm a developer, and to be fair, I'm a lazy developer, and I rather do development work and less lifecycle management work. But lifecycle management is important to keep your application secure. Can you recommend some tooling to make that a little bit easier and perhaps more secure?
Yes, I can do a lot of things, but I won't go too much into tooling names. I would make sure that you automate as much as possible, and you can either. I did some things with my own tooling on the command line, but you can do these things like plugins in your IDE. We supply a plugin, of course, so that you can use that over there. It depends on how you love to work. You can use a Gradle plugin or a Maven plugin that helps you with every build and scans your stuff. You can plug it in your CI system, and that's my opinion, don't only do it in your CI system because that's already quite late in your life cycle. And just like we want to have early feedback from your unit tests, I want to have early feedback on stuff I'm creating. So if I'm creating something in the creation process, I will scan it multiple times, just like I do with when I alter code, I run my unit test like a couple of times to make sure that nothing breaks, right? And then at a certain point, I'm done with it. I probably throw it into my Git repository, and my CI system runs, and then it's fine. But during development, you should already be aware what you're pulling in. So having tests in place and having things in place like automation in your Gradle or Maven environment or tooling in your IDE, just like you do with your unit test, is advisable.
Cool, great advice. And then Erik Heskes asks, would following the CIS benchmark security for Docker containers be helpful to chunk down and harden your Docker image?
Absolutely. Like these guidelines are nobody. Let's put it like this: they put in these guidelines to make it worse, right? But it's first of all, I don't think that a lot of people know about these guidelines. To be honest, I don't know them by heart. I have to look them up. I probably have read them once or twice. But these guidelines are there from a perspective from a CISO, so a security advisor board kind of thing level. A developer is not so much working on that pace. So if you want to be secure as a developer, you have to have at least the concept of what can I do? And as a developer, and yes, I'm a lazy developer as well, I can relate to that, Wouter. I don't want to do a lot of security. I want to build new awesome stuff with new frameworks. And if it works, I want to ship it. That's my state of mind. So if you do these easy things and have the easy tools in place that can help you out, like the automation I just said to you already keep away half of the bad guys. I won't say you're completely secure. And yes, from a security perspective, you should do a whole lot more. But we're a team, and I'm talking for here. I'm literally pointing to developers. So it's obviously a yes, but it depends.
It depends. Okay. With that, I have one final